Hamish, but a lot of people like to call me Bacteria. You know what I'm saying? That's my other name, aka Hamish. Hamish is renamed, but Bacteria, you can call me Bacteria. Now, Reaver Soldier. Let's get started, but one more time. You face right here, you FaceTime my channel, right? You click right there, you subscribe. If you FaceTime right here, you subscribe. Let's go. So they say suppose the function. So we have a different function here. This is exponential function. This is exponential function because it has a power exponential. And this is logarithm function because it has a log, so logarithm function. And this also is exponential. How? Okay, excuse me. E, if you plug in the calculator E is 2 point something. Let's see, E. So you play shifting E power 1. See the value of E, excuse me. 2 power something. Oh, my calculator, man. This calculator is not working. I don't know where to keep my calculator. Excuse me, forgive me. Oh my god. Oh, I got it. Sorry. Excuse me. I'm sorry. The other one does not work. Let me put it out of the way. Okay. E shift in. Power 1. Yeah, 2.718. So E is 2.718. So it's like if somebody give E power X, like 2.7 power X. 2.71 power X. You know what I'm saying? But don't write it as 2.7. No. Just know in your head like E, the meaning of E is that. Okay? Cool. Now, that's not part of the question. The question say, so that's exponential and this exponential because it has the power. Now, they say write down the sets of domain of G, domain of H, F and G. Now let's go. So let's start for F. So given here, fx equal to 2, 4x plus 3, 2x plus 1. Look, man, any number. Okay, so when they say domain is like, think of a number. Let me give another example, which is going to make a lot of sense then when you come in for the people who don't know how to get a domain of anything. If somebody give, let's say, for example, 1 over x. Let's say this f of x. What is domain? So domain, you think of, okay, which number is going to work in this function? And which number is not going to work? We know we never have any number, let's say 3 over 0. This is undefined. If you plug in the calculator, it's going to say error. Why? 0 should not be at the denominator. So that means this, any number can work here, means we can plug any value of x, except x should not be equal to 0. So for that case, we're going to say domain of x are all elements of real number, means any number, except this x should not be equal to 0. Because if equal to 0, it's going to cause trouble. It's going to cause you trouble. Dude, gonna cause you trouble. You know what I'm saying? So that's it. So for that case means, so you got a little idea like how you get the domain. Means you have to think of a number, which number gonna work and which is not gonna work. So for this case, domain is gonna be all the value of x except x should not be equal to 0, because if equal to 0 is gonna be a problem. Or if somebody give, let's say this is g of x, 1, let's say 3x minus 1. So we know all this stuff at the denominator. So don't look at it, which value of x. No. Take all the stuff at the denominator should not be equal to 0. Means for this to work, means this stuff it should not be equal to 0. But any other number is going to work. So I'm going to say 2x minus 1 should not be equal to 0. Means everything should not be equal to 0. And then after that, then you can simplify. You say this one go over. So 2x should not be equal to, go over 1 divided by 2 divided by 2. So should not be equal to a half. So domain, you're going to say any number is going to work. So we're going to say domain, if this is G, so say domain of G equal, you put your curly bracket, x are element of all real number, but this x should not be equal to a half. That's how you get the domain. So you have a little idea like how you get the domain, like you have to think of a number, which number cannot work and which number cannot, or which one can and which cannot. So for exponential function, this is like a rational. This is called rational function. So this is how you get domain of a rational function. Now, so for exponential, if any number works, either it's negative or positive, it does work. For example, if I have a 2 power x, any number you're going to put here, if you put negative later, it's not work. If it's positive or negative, it's going to work. Any number doesn't matter. Check your calculator, plug in negative. Let's say 2 power negative a half. It's going to work. Because this you can reciprocate. This 7 say 1 over 2.5. If we say 3 power negative 7, oh, this may say 1 over 3 power 7 because you reciprocate. You take this to the bottom. Say 1 over You know how reciprocate, check everything to the bottom. You know what I'm saying? So any number, if you put positive also, it's gonna work. Oh, so in any exponential function, any number can work. So domain of f, because everything is exponential, say domain of f are x are all element of real number, means any number. Or sometimes they write like this. Domain of f, and then here write means element of all real number. So for f, we're done. So now we know how to get domain of n exponential. Exponential function, any number, work. Okay? Now let's go for logarithm. So for logarithm, the one I did before, it was rational. Now so exponential, any number, it doesn't work. Okay, now let's go for logarithm. Now, what about logarithm? How do I get the domain of something? Which number works and which does not work? For example, if somebody give you, let's say log x. You know, when there's no base, it will be is base 10. Don't bother about it. Don't worry much about it. Okay, any number which is in front of the log. Take a calculator, put here -1. The calculator is going to reject. If you put -2, it's going to reject. Even any negative number, even a 0 is going to reject. But if you put, let's say 0.1, it's going to give an answer. Take a calculator, say log 0.1, log. So we see any number which is going to be whatever is in here. Listen, this is very, very important. Don't take as x, take as anything in front of the log. Like anything in front of the log, it should be greater than 0. Means it has to be positive number. So for this case, for domain, let's say this is f of x. I'm going to say the domain of f, means of f, x are element of real number, means x element. But whatever is in here, what is there is x. For this case, it must be greater than 0. This is the domain of this logarithm. For example, now, sometimes, how is they give you this now? For example, let's say f of x, or let's say g of x, log x squared over 5. I'm going to do the same thing. You know what I'm saying? I'm going to say, since this is logarithm, and I know in logarithm function, it's like you can even close your eyes. Logarithm function, anything in front of the log, it must be greater than 0. I don't have to look what is in there. Can you see me? Close my eyes. So this, you can even cycle. It must be. So it's okay. X are element of real number. This is the domain of G. Curly brackets. But anything which is here, take everything. It must be greater than 0. You know what I'm saying? And then from there you can multiply this 5. So say x are element of real number, whereby x squared is greater than 5. And then for this case here, you're going to say x I'm going to explain to you this at a time. Okay, let me explain to you now because it just came out. If somebody give you, let's say x squared, let's say greater than 4. What you do, when you must square root and square root, you get x plus or minus. But if it's inequality, don't write plus or minus. What you do like this. The negative one you write on the left, the positive one you write on the right. You know what I'm saying? That's how you do inequality. Like if somebody give you, let's say y square, even if they give like this, 9. You see, it doesn't matter even if it's faced that way. But when you square it, make sure you write left and right. So when you square it, you get plus or minus. The minus on the left, the positive on the right. Only for inequality. And then you write like this. And they put y. Even if it was facing the other side, you must face this. For example, m is the last one, excuse me, because this is not part of the equation. 16. What I'm going to do, I'm going to square root to say negative 4. And this is going to be positive 4. And then you change this to the left, always. And then you write your m. You know what I'm saying? So same here. So this stuff here is going to be x, excuse me, x, oh, whoa, yay, x, it's not positive 5, negative 5. You know what I'm saying? But if you look careful, we know this number should not be a negative number. You know what I'm saying? But I don't want to focus more on equality for now, but it should not be a negative number. So the main focus, whatever is in here in front of the log, must be greater than 0. For example, let's take another example. I don't want to start on inequality for now because this is not part of the equation. Okay, somebody give, for example, log. That was not a good example. Just waste your time. You know what I'm saying? Okay, somebody give log. Okay, let's see. X 2x minus 1 equal to 6. Oh, 2x. Find the domain of G. Oh, so anything in front of the log, it must be greater than 0 if there's a log. So I'm going to say domain of G equal to x, our element of real number, whereby anything in front of the log, what is in front of the log? This one, for this case now. We know it must be greater than 0. So for that case, this one will go over. So 2x greater than 1. And here you write x, our element of real number. Okay. And then what happened? Divided by 2 divided by 2. So when you divide by 2, it's going to be x greater than 1 over 2. And this is going to be x, our element of real number. You know what I'm saying? Okay. Yes. One more. The last one. Find domain of logarithm function. Okay, let's say this is a h of x. And then they give you log 3 minus 9x less than 3 minus 9. Find domain. So we know, oh, so this is a logarithm function. For logarithm function, anything in front of the log must be greater than 0. So I'm going to say domain of h of x equal to x, our element of real number, whereby anything in front of the log, which is 3 minus 9x, we know it must be greater than 0. You know what I'm saying? So what happened? This one go over. Don't take the one with the x, number. So this is going to be negative 9x greater than 0. Then this is positive, and go over is going to become negative 3. And then you can write exactly element number. So we divide by negative 9, we divide by negative 9. But remember, for inequality, when you divide by negative, the direction of the inequality change. See, so when you divide by negative 9 and negative 9, only if you divide by negative. So this is going to be x. You see, this direction is going to change. It's going to get opposite direction. So negative, positive. 3 divided by 9, 1 over 3. Only if you divide by negative, the direction of the inequality change the direction. You know what I'm saying? So that's how you get the domain for logarithm. So now, we want to get the domain of G. Oh, so this is a logarithm and this is a logarithm. So, man, it's going to be tricky here. Okay, easy. Let me show you. So first and foremost, I'll put them together because we have a logarithm rules whereby if I have a log of something plus log of something, base are the same, I can bind them together. So that's going to be g of x first before I do anything. I can say log, I'll put in a single log, and then base 3, base 3, can you see? Same log, base 3. And then I'll take this, multiply by them, because from the log of a plus log of b in mathematical, if they have the same base, so let's say log of a times b. So this is going to be log of x times this group here. That's a rule. You know what I'm saying? And then after that, why I do that? Because I want to bind them together. So from there, and then I'll say, okay, this all in front of the log must be greater than 0. So I'll say, okay, x plus 6 must be greater than 0 if we want to get domain of G, whereby x are element of real number. Now I'm saying, so this, I'll say either x greater than 0 or x plus 6 must be greater than 0. You know what I'm saying? So now we got two answers. This one is going to go over x greater than negative 6, and this is greater x greater than 0. Oh, so now which one are we going to take? So now we're going to have to test, because we got two answers and there's no way two answers are going to work for both. Now we're going to have to test, and one of them is not going to work. They say x must be greater than 0. Okay. For this one, x greater than 0 is going to work because we know n must be greater than 0. Okay, here, they say x must be greater than 0. No, this is not going to work. You know why? They say greater than 0. How if I put negative 1? Even negative 1 is going to work, because if I say log, okay, under 3, right? Okay, let me put negative 1 plus 6. You see, this is going to give us positive number, which is log of 3, which is going to work. So it's not true that this number, it has to be only greater than 0 for this case. Because even if I put negative 4, so it's going to work. But if I put negative 6, it's going to be a problem, because if I put negative 6, look, plus 6, see, it's going to give us 0. And log of 0 is problem, is undefined. Oh, so then how are you going to conclude? This is going to work, this one here. this is true. We say any number must be greater than -6. Is greater than -6. Okay. When you say something greater than -6 means it can be -5.9, -5, -4. For example, let's say -5. If you put -5 here, it's going to be log. If let's say because it's greater than -6 means if a number line look -6, -5, means these are greater. When you go this way, left is smaller. That's a greater. So -5. If you put -5 here, it's going to be -5 plus 6 equal to 1. So log of 1. Log of 1 equal to 0. 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 Remember that? Okay? Yes. So log of 1 equal to 0. See, it does work. You know what I'm saying? So we see this is true because any number which is greater than -6 is going to work. Even if you put -3, look. -3 plus 6 is going to be 3. And log of 3 is possible because this is a positive number. We know, you know what I'm saying? So this is true. So we say, oh, so this is not true. You know? So you can say this is not true. So you can just cancel here, say no. This is not and this is not. This is true. Only, so I can just say, so for that case, domain of G, x are element of real number whereby this x must be greater than -6. We don't. So we want to go for h of x. h of x is exponential. We know for any exponential function, any number does work. So for d of h, when they say just a real number, means domain of h is a real number. So this is for d of h. You know what I'm saying? This is d of g, this is d of h. Means any number is going to work. Put any number there, 1, 2, 3, and like I say, the value of e is 2. I can't remember, 2.7 or 187 or something, 27 something. You can check out, you can plug in the calculator. So this is like exponential. It's like 2 power 4x, 10 times 2. So we know any exponential function, any number it does work. It doesn't have this other condition. So we're done for 1. We go question 2. Solve the equation. Go question number 2 now, man. This one is done. Okay, so number 2, they say solve the equation of f of x. Oh, so they give us f of x equal to 16. But what is f of x? Oh, we have f of x. This. So instead of this f of x, I'll say 2, and then this is going to be 4x. And then we plot 3, and then we got 2x plus 1, and then equals 16. But this is quadratic. I'm going to show you how. Look, so what I'm going to do, I'll say this is, let me say 3. And this is going to be 2 power 2, because from mathematical rule, if I have a 2x plus 1, I can say this power that multiplied by this power that. Same thing, you know what I'm saying? Means base the same, you add the power, you know, for mathematical rule. So 2 power 1 equals 2. So this, let me say 2 times 2 power 2x. So instead of this, I'll write this one. So now instead of this, I'm going to say, I'll start with the 2 phase, and then 2x equal to 16, and here I have, look, 2 for x. So 2 for x, I'm going to have to use a common sense. Okay, let me write phase, and I'll show you what I'm going to do. Okay, 3 times 2 equals 6, so this equal to 6 plus, and this is going to be 2x equals 16, and this, look, I want to make it look like this. You know what I'm saying? That's why I say this is quadratic, but I kind of play with your brain. So how I'm going to make it this look like this? So whenever you have this type of question, try to make something look alike. So this is, let me say 2x power what? Power square. Can you see? This look like that. So for that case now, since they look alike, I can let. You know what I'm saying? I'm going to let. So let. These are the look alike. 2x equal to Hamish. Sometimes they like to say k. You know what I'm saying? You can use a k, or they call it k substitution for the most cases. For the lower grade, they like to say k substitution, memorize. But you can substitute any letter. But most of the books they like to say k or m. Okay, so let's say k substitution. So this equal to k. So instead of this, I'll say k here but there's a square plus this is going to be 6, and this is going to be k equals 16. So you see it's quadratic. This is going to come back. So k squared plus 6k come back here, minus 16 equal to 0. So for that case, this is a normal quadratic. You know what I'm saying? If it's normal quadratic, I can use the general formula. Okay? Use the general formula here. So I'm going to do this. I'll say, okay. So for that case now, this is half is finished. Factorize, or you can solve use general formula. So general formula, or you factorize. Whichever is going to be easy for you, you do. Excuse me, I want to drink some water just a minute. Okay. So whichever thing is better for you, you can do. Okay. Now let's do general. Okay. Now general formula. Okay. Let's see. Okay. Let's factorize. Equal to 0. This k squared. This must be k. This must be k. Now let's think. 16. 18 2. Yeah, 18 2. So this is going to be 18 and this is going to be 2, but the middle number is positive, so this is going to be positive on a bigger one, and this is going to be negative. Let's see. K times k, k times k squared, k times 18 plus 8k, negative 2 times k, 2k, and this is plus 16, and this is going to be 6k. Yeah, it's true. So this is true, so I'm going to say this equal to 0 or this equal to 0. So either k minus 2 equal to 0 or k plus 8 equal to 0. So now we come here, let's finish up. So for that case now, 2 is going to go over k equal to 2. So k equal to, or this one go over, so it's going to be k equal to negative 8. But I will know the value of k, so you have to substitute back. So say insert back. Insert back. What you insert back? You insert back what? Remember k came from here. So you insert back, instead of k, now you bring back 2 power 2x equal to, or instead of this is this, equal to 2, and this is going to be the same thing. Instead of k, you say 2 power 2x equal to negative 8. This is not going to work. Whenever you have exponential and the other side is negative, problem is undefined. It's not possible. You know what I'm saying? Means you have exponential and the other side is negative. For example, if you have a, let's say 5 power x, and this is negative 25. No, this is error or undefined. It must be same sign. If here is negative, yes, it can win. But if it's one side is negative, error. Okay, but this is now by exponential, so I don't want to jump and focus on exponential. You know what I'm saying? So for that case, this one is going to be undefined. This is undefined here because there's a negative on one side. So this is undefined. But this it does work because you know what I'm going to do? There's no power here, means I can say power 1 because it doesn't have a power. So for that case, when bases are the same mathematical, the power must be the same. If last somebody a power x and a power 2, bases are the same, means x equal to 2, means this must be equal. So for that case, bases are the same, so it's going to be 2x equal to 1. Compare the top one. So for that case, I'll divide by 2, I'll divide by 2, this and this cancel, so my x equal to 1 over 2. So I got my value of x equal to half. Solve the equation of x equal to 16 for x. We solve with an x equal to half, x equal to half. Okay, now let's go for 4. Question 4. Drink some water. I feel so thirsty. Where's my water? My water. Oh man, I can't see how I'm going to solve this. Okay, question 4. Oh, I got it. Sorry, excuse me. Excuse me. I want to drink some water. Okay, cool. Now let's go to the next question. We finished, almost finished. Okay, cool. Now let's go for question 3. Question 3. Okay, they say solve the inequality of g of x. Oh, so now g of x is greater or equal to 0. What is a g of x? We know. Let's see the place. So instead of saying instead of saying g of x, I'll write that. So this is log and then we got x base 3, and then we plus, and then we go log, and then we go 3, and then we got x plus 6, and then greater or equal to 0. Notes. This is very, very important. So exponential rule. Let me show you something called exponential rule. Exponential rule. Exponential rule. What is exponential rule? Not. This is not right. Don't write an exam. Not. So for exponential rule, if somebody give a log, let's say this x under base a equal to p. If you want to apply exponential, means look, you push this to the right. You see this on base, this base, push it, like push to the right. So it's gonna come here. See? So here I'm gonna be left with only with x, and then this is gonna come here a, and this is gonna go to the top. So you see it was log, it became exponential. So how am I gonna know when I'm gonna apply exponential rule? You apply exponential only when you have a log on one side. Only when you have a log on one side. Excuse me. So if somebody give let's say log, let's say y, okay, equal to 0. Yes, I can apply exponential, but this is tricky, man. Huh? There's no base. Oh, we know when there's no base means base under base 10. So then give a base means I'm gonna write base 10. So I push that. So this is going to become 10, and this is going to go to the top as the power, and here I'm going to be left with y. The log disappeared. Huh? Even here the log just disappeared. That's exponential rule. So any number past 0 go to 1. So 10 past 0 go to 1. So y. So this is exponential rule. Last one, exponential rule. So somebody give x minus 1 log 2, let's say equal to 1. Can you apply exponential rule? Yes, we can. How? Oh, how did you know it? Because I know because there's a log one side. So if there's a log one side, means I can push this one here. It's not okay. You know what I'm saying? So for that case, look, there's a log one side. So what I'm gonna do, I'm gonna push this one here. It's gonna be 2, and this is gonna go to the top is the power. So here I'm gonna left with x minus 1, and log disappears. So 1 is gonna come over. 2 power 1 equal to 2. 1 is negative. When it comes over, it's gonna be plus 1 equal to x. 2 plus 1 equal to 3 equal to x. Oh. You know what I'm saying? So now here there's a trick with exponential. Show me that trick, please. Show me that trick is easy, man. So what I'm going to do, first of all, I'm going to put them together. You know why? Because I want to apply exponential, but there must be one thing from the product rule or additional logarithm of logarithm. Base are the same. So if base are the same, I can bind these two things. I'll say this. Let me say x and then x plus 6, and I'll write only one log in the base 3. And then greater or equal to 0. Oh, here I can apply exponential rule. Okay. How? Because there's a log one side and there's equal to something. You know what I'm saying? There's no log in the other side. Let's apply that exponential. So what I'm going to do, I'll push this one here. So this is going to be greater or equal. This is going to be 3 power 0. And here I'm going to be with x and then x plus 6. Okay. And then I'm going to 0 equal to 1. So this is going to be 1 greater or equal to x. You know what I'm saying? Let me see. Greater than 0, just say greater than 0. Oh, I'm wrong. It's not greater than 0. Greater than 3, baby. Greater than 3. So this must be 3. My apologies. So this must be 3. And this must be 3. So this is going to be 3. And this is going to be 3. What you gonna do? What you gonna do? What you gonna do? 3 times 3 equal to 27. Oh yes, now. So now you got x plus 6. Okay? So now this is quadratic. How? So can't you compare? No, never compare quadratic if there's no 0 here. Don't say x equal 27 and this equal 27. No, you only do that when there's a 0. Okay? Yeah. So for that case now, I'm going to multiply in this going to be x squared, and the x times 6 is going to be 6x, and this is going to come back minus 27 greater or equal to 0. So now I can factorize. How do I get x squared? This must be x and this must be x. How do I get negative 27? One must be 9 and one must be 3. But the middle number is positive, so in the bigger number I'm going to say positive. And how I'm going to get negative 27? This must be negative. This and this, negative 27, x times x, x squared, and then x times 9, 9x positive, negative times 3x, negative 3x, 9x positive minus 3x, 6x is true. So for that case now I can compare this is greater than 0 and this is greater than 0. Why? Because there's a 0 there. And the question is finished. And now we're going to do the last one. Very soon. The last one is similar method, just like this one. Yeah, this question are easy, guys. You know what I'm saying? Okay, cool. So for that case now, what you gonna do? What you gonna do? X minus 3 is greater than 0. Equal to 0, or x plus 3, x plus 9 plus 9 equal to 0. So for that case, now, so we say x greater or equal to 3 or x greater or equal to negative 9. So these are values of x when g of x is greater than 3. You know what I'm saying? So they say solve inequality of g of x when it's greater than 3 for x. So these are values of our x. Now, I think it's good also we can test to see which one is true. Now, if I put 3 here, you know, because this is solve h of x for which, question, excuse me. Solve the inequality of g of x, okay, now, let's see if it's true. X greater than 3. If you put greater than 3 here, it's going to work. Either can be 3 or greater than 3, even here. If it's 3, it's going to be 3 plus 6 equal to 9, or even if it's greater than 3, let's say 5. 5 plus equal to, okay, now let's come here, they say greater than negative 9. Greater than negative 9 is going to be a problem. This is not going to be the value, because if I put negative 9 here, it's going to be error. Because they say equal or greater than negative 9. Let's put here negative 9. See, log of negative 9, error. Come here, negative 9. Negative 9 plus 6 equal to negative 3. Log of negative 3, error. So I'll go for this one. Personal, I'll say this is not. So here, I'm going to cut it here to say no. Or not answer, or you can say this is not answer, not defined, or we can say this. Say here test. Let's test. You know what I'm saying? So after you test, you see this is gonna work, this is not gonna work. So when you say x, you can write like this in example. 3. That means x equal be 3, 4, 5. You can test there. Say okay. Let's say log, okay, so g of, let's say 3, means instead of x you say 3, so this is going to be 3 under base 3, means 3, and that's x3 plus log of 3 plus 6 equal to 9 under base 3, and this is going to be log of 1. Now I'm saying this is log of 1, but what is log of 1? Log of 1 equal to 0, so this is like equal to 0, because it's going to be log of 1, but this log of 1 is like, okay, like a 0 plus 9. 9 is like log of 9 over 3. This is going to be log of 3 power 2. And this 2 is going to come back. 2 log of 3 under base 3. This equal to 1. So 2 times 1 equal to 2. Oh, I'm wrong. My apology. What am I doing here? Shows me my apology. Yeah, I'm wrong. I'm better wrong. I'm wrong. Shows me here. This is correct because this is equal to 1. Not. It's something I need to write down for you guys. My apology. Note. Log of 1 equal to 0, but log of the same thing equal to 1 means when base and this is the same, and log of 0 is undefined, or log of negative number is negative and undefined. So here I made a mistake. Which mistake did I say? What did I say? I say these. What did I say? Excuse me, I can't see the. I say when it's 3. I say this equal to 0. No, it's not equal to 0. This equal to 1. So this equal to 1 here. So it's going to be 1 plus. What is 9? 9 is 3 square. So it's like say 3 square log under base 3. And these two go to the back 2. So we got log 3 under base 3. And this equal to 1. So 2 times 1 equal to 2. You know what I'm saying? So it's like 1 plus 2 equal to 3. So we see any number. Like even if you put 4, even if it's not gonna, you're not gonna get like actual number, but if you put in a calculator, it's gonna give a certain value of, because it's greater than 0. If you put 4 here, 4 plus equal 10, so log of 10 base 6. Any positive number, if you put in a calculator, is gonna work. But for this one, no, because they say it has to be greater or equal to negative 9. If you put negative 8 here, it's not gonna work. Log of negative 8 is error. Log of negative 8 plus 2 negative 2 means negative 8 plus 2 equal to negative 2. Log of negative 2 error. So this is not. So you can just stop here and answer, say, or you can test and then you can disprove them. Like for this one, but for f of, they say equal negative 9, and then you put here negative 9, which is going to say is undefined. 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 So for that case now, only this, only this not defined. You know what I'm saying? So now we go for the last question. We're going to do the same similar approach. Excuse me, sorry. Now let's do this last question. I'm going to go speed because this is very similar to this one. Okay, cool. Now for the last one, they say h of x equals negative 9. Okay, let's go. H of x equal to negative 9. Negative 9. Okay. But we know h of x. H of x, what is h of x? Is that exponential function, which is e. And then we got 4x. And then we got 10. And then we got e 2x equal to, instead of h of x, we have h of x, this. So we replace here h of x with this, and then equal to negative 9. So don't you see this is similar to what we just did now? You know what I'm saying? So let's say, okay, see this is e power 2x. So let's make this e power 2x. It's going to be e 2x, but since power 4 means outside it's like there's a 2. So you give it 4. Minus 10, and we got e 2x. Bring this one back, it's going to be plus 9 equal to 0. Why do they? You know what I'm saying? Because I want to make quadratic. So we have to let, you can let m, whichever letter, let m. Okay, excuse me, sorry. E 2x. So instead of saying this, I'll say m. It's going to be m squared minus 10 m plus 9 equal to 0. So you see now we have a quadratic now. You know what I'm saying? So now we have a quadratic. So how are we going to solve a quadratic? We say, okay, so now, how are we going to solve a quadratic? Let's say e 4x minus 10. Okay, negative 9, come back. Okay, so now, this I'm going to say, forget m squared, means this must be m and this must be m. How are we going to get 9? Means 1 must be 9 and 1 must be 1. But to get negative 10, this must be negative, this must be negative. Look, m times m, yeah, this is same as that one. When you factorize, I believe you know how to factorize. So for that case, this equal to 0 and this equal to 0. You know, so m minus 1 equal to 0, or the second one, minus 9 equal to 0. Hey, what you gonna do? Take over. So this m equal to 1 or this m equal to 9. So this I can come and use here. But I want the value of m, so we have to substitute back. But our m, we say equal to e2x. So you can say substitute back, or you can say insert back. Substitute back, or you can say plug back or insert back. You know what I'm saying? Insert back. Okay, cool. So now instead of m, we know the value of m. M equal to 2x. Now 2x equal to, we know this equal to 1. And also m equal to 9 means 2x equal to 9. No. Come on, it's e, man. What am I doing? Oh my god. Okay. E. Not 2, baby. It's e. Okay, so our e equal to that one. So what we're gonna do now? We're done. So what I'm gonna do, listen, this is very, very important. Note. If somebody give, let's say e, let me use that card. My pen are finished right now. Note. If somebody give you e, let's say x, equal to, let's say any number, let's say 2. For you to get, if you have an e here, and you want to get the value of x, apply ln throughout. Only if you have an e, apply ln. Not only, even other one, but if you have exponential, especially e, apply ln. So I'm going to say ln of e3x, left and right, ln of 2. If you have an e, Yes. Cool. So now if you have E, let's go. So now this, we're going to take over, it's going to be 3x. Ln of means this can come back, and then write ln of E because it comes from, and then this is going to be ln of 2. Not. Ln of E equal to 1. Ln of E equal to 1. Not that. Ln of E always equal to 1. You note it. You gotta keep not. So it means this is going to be 1 here. So it's going to be 3x times 1 equal to 3x equal to ln of 2. Divided by 3 because this is going to be 1. So 3x times 1 equal to 3x divided by 2. So my x equal to ln of 2 over 2. Only if you have a ln. You know? And another thing you should note also, ln of 1 equal to 0. Now let's go. So what we're going to do there, since there's an e and a power which is unknown, so I'm going to apply ln throughout. So this one here is going to be ln e 2x equal to ln of 1, but ln of 1 equal to 0. So 2x is going to come back, it's going to come to front. I don't know you call front or back. Most of the time I say front, I always say back. But most of people say, no, Hamish, you're wrong, it's front. So I don't know which is front, this way or this way. Okay, let's go to your way. Front, because most of you say front. So this is going to come to the front, it's going to be 2x. And here it's going to be ln of e equal to, what is ln of 1? Equal to 0. 0. So ln of e equal to 1. Ln of e equal to 1. It's going to be 2x times 1 equal to 2x equal to 0. So 2x equal to 0 divided by 2 divided by 2. Divided by 2 divided by 2. So our x equal to 0. So we got the value of x. You know what I'm saying? The value of x equal to 0. Now, let's count for this one. So for that one, I'm going to raise here and make a space and finish up, man. What you gonna do when paper left for you? But for this one, we got e, 2 and x equal to 9. So since you have an e and unknown power, apply ln throughout. Ln of 2x and here ln of 9. 2x come to the back. 2x ln of e, ln of 9. Ln of e equal to 1. This equal to 1. So it's going to be 2x equal to ln of 9 over 2 and over 2. This and this goes. So our x, my pen up finish. X equal to ln of 9 over 2. And they didn't say here in terms of ln, so we are necessary. So this is a final. So you can write as a x equal to 1 over 2 ln of 9. What you gonna do? What you gonna do when back boy look for you? What you gonna do? What you gonna do? Yeah! Oh! Hey! Oh! Whoa! 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 And that's how we go. 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 Ln of 9. We're done. I'm out. Peace.